We can use the equation of the potential divider, which is V1 over V2 equals R1 over R2 for the two resistors connected in series. But here this relation will not get us to the required because V1 is not known, we want to know it, and V2 also, so we cannot use this equation. We can use the equation V1 over V equals R1 over R, where V is the potential across the whole circuit, potential of battery, and R is the total resistance across the circuit. Then V1 will be equal R1 over R times V, which equals 40 over 60 times 15, which is equal to 10 volt. Electricity supplied to a town is transmitted using a high voltage cable. Transformer in town has a soft iron core. Explain principle of soft iron core transformer. It begins when alternating current passes through primary coil. It produces changing or alternating magnetic field. And this magnetic field is transferred by iron core to the secondary coil. So secondary coil cuts lines of changing magnetic field, which produces EMF in the secondary coil. Okay. If the transformer steps down voltage from 220,000 volt to 33,000 volt, there are 45 turns on secondary coil. Calculate number on primary coil. Equations is well known. VB over VS equal number of primary over number of secondary. So number of turns in the primary in B will be equal VB over VS times NS, which is equal VB 200,000 over 33,000 times NS, which is 45. Here is your calculator. Answer will be 3,030. The electrical power transferred to the transformer by high voltage cable is 77 megawatt. Calculate current in primary coil. You know that power is equal to I times V. So if we have the voltage and power, we can get current, which is power over V equals 77 times 10 to the power 6, because it is megawatt, over the voltage supplied to primary coil, which is 220,000. Will equals 350 ampere. the following figure represents the neutral atom of radioisotope X1. Determine number of neutrons and explain how the answer is obtained. If we see the little sphere here, which represents the electrons, we will find that they are 5. So we expect for a neutral atom to have 5 protons to make the atom neutral or electrically balanced. So we have here 5 white spheres, small spheres, which will represent the protons, and the dark sphere will represent the neutron. Okay, so the number of neutron will be 1, 2, 3, 4, 5, 6, 7. Will be 7, and explanation that number of protons equals number of electrons for neutral atoms, and number of electrons equals to 5, so number of protons equal to 5 and the number of neutrons equal to 7. The isotope X1 is beta emitter that decays to stable isotope X2. Describe how a nucleus of X2 differs from nucleus of X1. We know that for beta emission, a neutron is transformed to a proton and electron. The electron is a beta particle, and the proton stays in the nucleus. So the X2 nucleus has one proton higher and one neutron lower. So this is why isotope X2 is stable, whereas X1 is not, because X2 has lower number of neutrons. Neutrons are the source of instability in the nucleus or source of radioactivity. Half-life of X1 is approximately 20 milliseconds. Define term of half-life is time taken by radioactive nuclei to half, or time taken by decay rate to half. Suggest one reason why isotopes with very short half-lives are especially hazardous: because large number of particles are emitted per unit time, or it have high decay rate. Okay. Finally, the question on space. Pluto is dwarf planet, and this is the direction around the sun, and X is the closest point, Y is the furthest point from sun. Describe how speed of Bluetooth varies as it moves from X to Y and then back to X. You should remember that for orbital motion we have two special points, the closest point and the furthest point. And for every one of them we should know the difference in terms of gravitational force, kinetic energy, and gravitational potential energy of the planet. With respect to the force, it is maximum at the closest point, while it is minimum at the furthest point. Gravitational force inversely proportional to the distance, and gravitational kinetic energy increases at the closest point, so it is also maximum because the effect of the gravitational force is maximum, so change in velocity direction will be maximum and kinetic energy will be maximum, while gravitational potential energy is the minimum and the reverse in the furthest point. You should always remember this table. So how speed of Bluetooth varies from X to Y and then back to X, which means from Y to X. From X to Y, we are moving from maximum kinetic energy to minimum. Okay, so it decreases, V decreases, and it is the opposite from Y to X, V increases. In terms of energy transfers, Y speed of Bluetooth varies in this way because we know that both kinetic energy and gravitational potential energy is constant, and in X kinetic energy is maximum and in Y kinetic energy is minimum. So from X to Y kinetic energy decrease and gravitational potential energy increase. You can repeat the same two lines with respect to Y, with respect to, gravitational potential energy. Okay. Average temperature on surface of Bluetooth is 43 Kelvin. Convert this temperature value in Celsius degrees. We know that 1 degree Kelvin is equal to 1 degree Celsius plus 273. So temperature in Celsius for 43 Kelvin is 43 minus 273 degree, which is equal minus 230 degrees Celsius. Okay. Bluetooth has a white surface. As Bluetooth rotates, the white surface alternately faces towards and away from the sun. Explain how this affects the temperature of Bluetooth as it rotates around its own axis. Here we should remember that white surface is a good reflector, while black surface is good absorber and good emitter. So we can say that white surface temperature increase less than black surface temperature when facing the sun, and white surface temperature decreases also less than black surface temperature when facing away from sun. Okay.